Hello and welcome back to another video. In today's video I want to talk about functions. What are functions and why are they really useful to us in math? So let's start with what is a function? A function is just a mathematical principle or idea, construct really, that relates two variables to each other. What is the relationship between something like x and y? And why is that important? Well, we can go ahead and use two variables to model a lot of different things in the real world, which is where the real utility for functions comes from. Anytime you want to compare data, you're going to be using functions. And let's go ahead and look at one of the first and probably the most basic way that you get introduced to functions. So we start with something like this. Y is equal to mx plus b. So here, y is our first variable, x is our second variable, and then we would have m and b as constants. So, well, I lost my color I had, but it's fine. I think that's close enough. So, m is our slope, and b is our y-intercept. And so this is going to tell us a lot. It's going to tell us the relationship between y and x. And let's go ahead and look at what that might look like. So y is equal to 5x minus 2. What we do is we just start by plugging in numbers for x. So we're going to go ahead and make a little table here with x on the left and y on the right. We're going to plug in 0, 1, 2, 3, 4, and 5 in for x, and we'll see what we get out for y. So we can take 5, and now we're just going to plug in our value for x here where it's 0 into here where it's x. So here we can see we plug this in, we subtract, 5 times 0 is 0, minus 2, so we get negative 2. And now we can just keep doing the same thing. So here we get 5 times 1, which is 5, minus 2, which is 3. Again, we're going to plug in 2. 5 times 2 is 10, 10 minus 2 is 8. Here we're going to plug in 3, 5 times 3, minus 2, 15 minus 2 is 13. 5 times 4 minus 2 is 20 minus 2, which is 18. And then 5 times 5 is 25 minus 2 is 23. And here we're going to start seeing some rather interesting things. So the difference between each of these jumps is 5. Oh, that's an awful 5. Is 5. Each jump, we're increasing by 5. Now that is relevant because 5 is our slope. So we're jumping by our slope each time, right? We have 5 up here, and we're just jumping by our slope. Now our first one, when we start at 0, we're going to start at our y-intercept, which is negative 2. So here we start at negative 2, and now we're just increasing by our slope each time. So start at negative 2, go to 3, go to 8, go to 13, 18, 23. And now what we can do is we can take these numbers and we can create a graph. Let's go ahead and draw out a graph. Let's make that a little better. Draw out a graph. Here we're going to have x, here we're going to have y. So we're going to start, and we need some negatives as well. So this is going to be negative y, negative x. We don't need to go very far. So here, at x equals 0, we have negative 2. So we're just going to go 2 down, say right there. Okay, and let's go ahead and make some marks all the way up. just so that we can plot these slightly easier. Should be enough. And then same thing over here. We're just going to plot a bunch of lines onto our graph. So when x is 0, y is -2. When x is 1, y is 3. So we're going to have a dot here. When x is 2, y is 8. So we're going to go up 1, 2, 3, 4, 5. Right there. And so every time, the jump between each of these dots should be the same. It might be a little off here just because of my drawing, but it should be about the same. So here we have another one right about here. And so we start seeing this line that we're making. And so we're graphing our x coordinates and our y coordinates, and we're getting a line out of it, which is really important because essentially what we're doing is we're looking at the relationship between our x and our y. What happens? Well, we see y grows a lot faster than our x. If we had something like y is equal to x in the graph for that, then the graph is going to be nice and even up the middle. Because when x is 5, y is 5. Oh, just 5. And so on. So we start our journey with functions, typically around slopes and lines. And we don't really introduce them as functions, but this is where we start, and it's rather important to get a grasp for this. So now we move on. Another really important idea when we're learning about functions is dependent and independent variables. So, what exactly is a dependent variable, and what exactly is an independent variable? Well, a dependent variable is exactly what the name suggests. It depends on something else. So here we have y is equal to mx plus b. Our y is dependent on what our x value is. That's why we plotted our x first, and then we plugged those in to get y. So let's start with our independent variable. An example of what an independent variable would be, like a unit for an independent variable, would be time. Time is one of those independent variables that's used over and over and over again. And then dependent variables, so what depends on time? Well, we can look at a lot of different things that depend on time. So example for that would be position. So where are we with respect to time? Well, if we're looking at a graph like this, as time moves forward, we're further and further away from some sort of object. And as time would continue to go on, we would be even farther away. We can also change it to be anything really, so time and cookies, right? Like if you're somebody who bakes a lot of cookies, then that would kind of look like a step function. So here, this is our first batch of cookies that we make. This is time down here. It's going to stay the same until we're done with our second batch of cookies, which is going to stay the same for some amount of time until we make our third batch of cookies. So this is a step function, a different type of function, but we're still plotting a line. It's just not a continuous line anymore. So that's kind of the idea between independent and dependent variables. What depends on what? Here, our cookies depend on time. And of course, independent variables could be different also. So, for example, we could have cookies and cookie pans. So if we have cookie pans as our independent variable, then let's say we have this. Well, if we have one cookie pan, maybe we can make a nice 20 cookies. If we have 2, we can make 40. If we have 3, we can make 60. And if we have 4, we could make 80. So that's another example. It doesn't have to be time, but typically we will use time. But it can really be anything. So that's what a dependent variable and an independent variable are. Now let's move on to why do we change the function notation from y to f of x. F of x you'll typically see probably once you get to algebra 2. You'll see a lot more of this than you will y. And there's an important reason for that. F of x clarifies which variable is the independent variable. So f is our function on x is essentially what we're doing. So our function on x is equal to y. And what that means is x is our independent variable and y depends on x. So we don't have y without having x, and that's kind of what this notation is saying. It's saying x is our independent, y is our dependent, and so you would see f of x is equal to 5x minus 4, or 2 like we had earlier. So that's just a slightly different notation for the same meaning. And why do we do that? Well, like I said, independent variable, we can see it automatically and we know what we would be plugging in or what it's depending on. But also, now we can have multiple dependent variables. So maybe this is 7x minus 3. We can have h of x, which is 2x plus 7, or whatever, it doesn't really matter. So these are all dependent variables which depend on x. So that's kind of why we changed the notation. X is typically always going to be our independent variable, especially in lower classes. Once you get to higher classes, though, you might start seeing a change in notation. So, like I said earlier, one of the common things that we use for our independent variable is time. So, instead of f of x, you might see f of t, where we use t as the variable for time. That's pretty much the entire reason why we change it. We just can have more dependent variables and we can have multiple independent variables, and it makes sense for what is depending on what. So one of the big ideas for functions is that for 1x, so if we have x equals 1, then we can only have one y value. So again, if we're looking at something like this, and let's say y is here, or this is x equals 1, then we can only have one y value for that. Otherwise, it's no longer a proper function. So, for example, if we had something like this, where at one point here we have 3 different values for the same x, that's counterintuitive, it doesn't really make sense, and it's not really helpful. So for each x value, we can only have one y value at that point. Now that being said, our y values are allowed to be the same. So here, 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 or give or take, it's a little crooked, but let's just go from here to here. Our y values are the same. but they're at different x's. So this is perfectly fine. That's fine. This, it's not allowed. And we have a name for this. This is called the vertical line test. So the vertical line test says for any vertical line on your graph, you can only have one y value at that line. So 1, 1, 1. So this here where we have multiple, it does not count. So for example, a circle does not pass the vertical line test. Even though you might use circles a lot in your math later on, it's not a proper function. So one last thing before we go, we can think of functions as machines. So we're going to have an input to the machine and an output to the machine. And sometimes you'll even hear this terminology used for functions as well. So our input is going to be x. It goes through some sort of function. So f of x equals 5x minus 2. And then it comes out as y. So we can think of functions as machines. We input some sort of independent value, and we get some sort of dependent value. So input, output. And it's just, the machine's going to change this input. It's going to multiply it by 5 and then subtract 2 from it, and then we'll get some sort of output. So a lot of the times it's perfectly fine to have this idea that functions are machines, which goes through and manually changes every single input value into an output value. And that's the basics of functions. They're like mathematical machines that take an input and give out a specific output. And we can go ahead and look at all the different things that we've gone over. So we have tables which we can use to show all of our input values and all of our output values. We have slopes which show what we're going to increase by for each variable, for each output or input. We have lines to help us model the relationship between the two. We have dependent and independent variables which tell us what depends on what. So if we have 4 cookie pans, we can make 80 cookies. If we have 3 hours to make cookies, then maybe we end up with 32 cookies, or whatever the math might be. We have a change of notation from y to f of x, which helps show what the independent and dependent values are, or what's the input and then what's the output. And we have the vertical line test, which tells us we cannot cross, or we cannot have multiple y values for one x value. If we have an x value, it can only have one y value. Now y can repeat itself multiple times, but x cannot. And then finally, we can think of functions as machines. And that's all. Thank you guys so much for watching. I hope that you enjoyed the video. If it helped you, if you gained any more knowledge, more insight into functions, please consider leaving a like, a subscribe, and maybe a comment telling me what your favorite part of the video was or what I can improve. Thank you so much, and I'll see you guys next time.